Once a vaccine is developed and shown to be both safe and effective, the vaccine needs to be moved from where it is produced to locations where people can get it. This process is called vaccine distribution. Vaccine distribution is the final step of the vaccine development process, and it is often a complex one. Many vaccines require special conditions, and those conditions must be maintained at all times in order for the vaccine to remain effective. Vaccine distribution can be broken down into 3 main steps: storage, transportation, and administration. The first step is storage. Vaccines are made of ingredients that may be sensitive to their environment. If these ingredients are not stored under specific conditions, they begin to break down and become less effective. If vaccines are not stored properly, they can become completely inactive. This means they will provide no protection against the disease they were developed for. Because there are different types of vaccines that all contain different combinations of ingredients, every vaccine is unique and requires different storage conditions. 2 important conditions that must be monitored when storing vaccines are temperature and light exposure. Many vaccines must be kept cold in order for them to remain effective. Some vaccines need to remain refrigerated at a specific temperature, while others must be completely frozen. No matter what temperature the vaccine requires, they must remain at this temperature throughout their entire journey, from production until they reach their intended destination. This process is called a cold chain. The cold chain starts as soon as the vaccine is produced at a production facility. Temperature-controlled storage areas at the production facility hold the vaccines until they are ready to be transported. Whether the vaccines are going only a short way or traveling long distances, they are placed in special refrigerated trucks that keep them at their optimal temperature. Once the vaccines reach their final destination, they are transferred from the cold trucks into cold storage inside healthcare facilities, where they will remain until they are ready to be administered to a patient. Some vaccines are highly sensitive to the amount of light around them. These are referred to as being light-sensitive vaccines. When these vaccines are exposed to light, their ingredients can break down and become less effective. In order to prevent this, these vaccines are packaged in specialized containers that help to block out any light. This ensures the vaccines will remain effective throughout travel. As you can see, vaccine storage requires very specific conditions to be met to ensure the vaccines will remain effective as they travel from production facilities to distribution sites. So, whose responsibility is it to ensure the environment remains controlled at each step of distribution? In short, the answer is everyone. This means manufacturers, distributors, and healthcare providers all must take precautions when moving vaccines. There are also significant safety measures in place to ensure vaccines remain stored under safe conditions. In fact, each vaccine shipment has a specific storage plan to ensure everyone involved in the process understands the specific requirements needed for that shipment. Each shipment is also clearly labeled with the expiration date of the vaccines it contains. Just like the food we eat, vaccines don't stay fresh forever. Over time, a vaccine could become inactive or less effective, which is why expiration dates are always included on the label, and they are disposed of once the expiration date occurs. There are also measures in place to ensure vaccines will not be improperly stored due to non-human errors. For example, if something breaks or malfunctions inside of a storage refrigerator and it cannot keep the necessary cold temperatures needed, temperature monitoring devices inside the refrigerator alert staff members. These staff members can then move the vaccines into another storage location that can maintain proper temperature. Many healthcare facilities also have backup generators so that refrigeration units can maintain temperature during power outages. Lastly, all cold storage locations undergo frequent maintenance to ensure they are in good condition. Once vaccines are safely delivered to their destinations, the final step of vaccine development can be completed: administration. Administration is when a healthcare professional gives or administers a vaccine to a patient. As mentioned earlier, how vaccines are stored and distributed can look very different depending on the specific vaccine. This is also true for administration. Dosage amount, injection site on the body, and route can vary greatly depending on what vaccine is being given. Vaccine manufacturers always include detailed administration instructions with each vaccine lot delivered, so it is easily available to healthcare professionals. These paper pamphlet instructions include dosage, administration site, and route information. Dosage is the amount of vaccine solution given to a patient. Dosage often depends not only on the vaccine type, but also the recipient's age and weight. Generally, young children get smaller doses of vaccines, while adults can receive larger ones. Vaccine dosages are very tiny, usually measuring between 0.5 milliliters to 1.0 milliliters. This is less than 1/4 of a teaspoon. Some vaccines may also require a second dose or third dose, spread out over a given time frame. There are also multiple sites on the body where a vaccine can be administered. The two most common locations are in the upper arm or thigh. This is because these areas tend to have more muscle and fat tissue, which has a connection to our immune system. In our muscles, there are many immune cells available to recognize the given vaccine and help the body remember how to fight off the disease later if needed. Also, these areas of the body are fleshy. In other words, they have a larger amount of tissue than other places. This is beneficial because receiving an injection into an area with lots of tissue is less painful compared to areas with less tissue. Where in the body a vaccine is delivered is called its route. The vaccines that are administered into muscles have an intramuscular vaccine route because the dose is delivered into the muscle. Using an intramuscular vaccine route is the most common method for administering vaccines. However, not all vaccines are administered intramuscularly. Other vaccines can be given into the nose, which is known as an intranasal route. This process is done by spraying the dosage into the patient's nose while they simultaneously breathe in, allowing the vaccine to travel into the body. Finally, the last common vaccine route is the oral route, which can be administered using pills or a liquid dropper. After the vaccine administration process is completed, the healthcare professional will document what vaccine was administered, the date it was given, dosage amount, vaccine manufacturer and lot number, and the location of the healthcare facility where the vaccine was given. This information is usually provided to the patient on a printed card that they can take with them, ensuring that they have a detailed account of their treatment in case it is needed later. Overall, this process helps to keep everyone safe. Vaccine storage, distribution, and administration are the last steps of the vaccine development process. Remember, this process will look different depending on the specific vaccine, because every vaccine is unique. This process is carefully monitored along every step of the way to make sure that vaccines remain safe and effective for everyone.